Hey y'all, welcome back to the studio. It's been a while, but today we're going to talk about something that a lot of you have been writing me about, and that is fans. How to properly set them up, how to calibrate them, how to set those curves. So I'm going to show you how I went and set mine up. First thing I want to talk about is I am not a computer expert. I've just, I've had a few months to play around with the new rig, and I feel like I've got a pretty good understanding of what you need to do to get the machine in tip-top shape. We're also not going to be doing any overclocking in this video. We'll get there, I promise, but I wanted to become familiar enough with the machine running at stock before I really started to experiment with anything more intense. So today it's just about the bare essentials. How do I set up fans? So let's get to it.
And here is my awesome rig, abiding by the #1 rule in keeping your PC clean, and that's elevating it up and off the ground to keep it away from all that nasty dust and hair that this monster is going to create. Hey Chopper! Now because I didn't talk about RGB in my build video, let's talk about it here. The AIO fans are all daisy chained together. The exhaust fan is connected to the 3 Fantex fans at the front because it is a Fantex fan. Now the case, it has a connection in this back corner that has a universal output to connect the 3 AIO fans and a proprietary Fantex connector to connect all of the Fantex fans. Now these were originally connected to the motherboard, but Gigabyte's software sucks, so I disconnected it. In terms of power connections, the exhaust fan is connected to the System 1 input at the top of the motherboard. The AIO pump is connected to the pump input at the top of the 3 inputs on the side. The top Fantex fan is connected right under that, the middle right under that, and the bottom Fantex fan is connected to the other system pump input at the bottom of the motherboard. These fans are connected separately so I can have more individual control. The AIO fans, just like the RGB, are daisy chained together and are plugged into the CPU input at the top of the motherboard. Okay, so you've connected everything, it turns on, everything's spinning, the lights are on, you've installed Windows onto your computer. So the question is, what now? Well, the first thing that I did was I wanted to learn more about my computer. And there's a bunch of free software out there that tells you exactly that. The one that I use is Open Hardware Monitor, which, when opened, looks like this. And in here, you can see a bunch of information about all of your components so that you can just learn a little bit more about how your computer functions on the day-to-day. Now, what I also really like about Open Hardware is I don't have to leave this thing open. Instead, there's this little box in the corner that you can set to be always on top that is going to tell you the temperature of your CPU as well as a load readout in terms of a progress bar. So this will max when it's at full load. And then the 3080, same thing, my GPU, the temperature, and then as well as the load. So that way, you only need to use this when you're looking to set any benchmarks when you're running something that is going to be full screen. So this is a video about calibrating our fans, about setting those curves and making everything as optimal as possible. So we're going to need a different software for that. And it's going to be different based on which motherboard manufacturer you have. For me, I have Gigabyte, and in which case I use their System Information Viewer. Now you can also do this through your BIOS, but this connects to my BIOS, so for the ease of showing you, we're going to do this. And you can see that it has a few auto settings. So I definitely recommend just going with whatever base level, like in this case standard, just running it at standard and seeing as you use different applications, different games, just seeing what your temperatures get up to what your load looks like, just to give you a sense of how your computer is working when you do your normal functions. And then that will help give you a baseline for when you start actually messing around with your fans. So when you're ready to calibrate your fans, we can go here to your advanced setting where you can set your curves. Now these are already set by me. I've already tinkered these, so they're not default curves by any means. But here we can see our CPU input, which is my AIO fans, and right now it's not a lot is going on besides me recording this, so there's not a lot of load on my CPU, and therefore the temperatures are low and I could keep the fans low. There's a couple of different factors that you're thinking about. Really, it's temperature to noise ratio. That's really what you're measuring against. How loud you want your computer to be versus how hot you want to let your components get when they're under load. So we have our CPU, system 2. I have already decided, I've already told it where it is and what temperature reading to adjust to. System 2 is actually one of my top 2 front fans. So I have that set to the CPU. So here is a pretty good moment in which to talk about the placement of the fans and why I have them plugged into separate inputs as opposed to daisy chaining them together and minimizing the amount of inputs that I have. So back to the rig. All right. And here we are again. Now, because we use an AIO that has a liquid block over top of the CPU, it's not quite as easy as just making sure there's cool air flowing through the case. We have 3 120 fans at the front that are situated to suck in air through the mesh that is over the front of the case. You know that that's the case because of the plastic structure that's at the back of the fan. Shows you which direction the air is going to be blowing towards, in this case, into the case. So because we have a liquid block over top of the CPU, we want cool air to be sucked into the 3 fans at the top that are connected to our radiator so that it cools the water that's running through the radiator to come down into the CPU, absorb the heat from the CPU, and go back up through the radiator again. That means the majority of the air that we have exiting the machine, we want to have go through the top. However, we have an exhaust fan at the back that doesn't have a radiator for resistance that could just end up sucking all the air out. And some people with an AIO setup will actually exclude this fan because they don't really find a need for it since we want so much air going up through the radiator. In this case, it's the first example of why I have separated the fans into their own connectors instead of daisy chaining them together and putting them through one. So what I'm going to do is I'm going to walk you through what roles I have the fans taking in this current setup. The fans connected to the AIO are obviously feeding the CPU, and therefore they're connected to the temperature setting of the CPU, and they start to crank up as the CPU load increases. Because we want cool air going up into the radiator, the front 2 fans are connected to the CPU. So as the CPU load increases, the temperature increases, the fans then increase their rotations per minute, and more cool air is being sucked in through these top 2 fans so it can feed the radiators at the top. Now the CPU isn't the only thing that we have to consider. The GPU also heats up, and for this reason I have slaved the bottom fan to the GPU temperature. So when the GPU temperature starts to increase, when the GPU is under load, the bottom fan is going to start to crank up and push oxygen through that can then be sucked up into the GPU fans that are located at the bottom and rise upward. I do have a fan at the back, but again, I don't want it to rob the AIO of oxygen and just blow air out the back of the case. I have the 140 exhaust fan running at a very low setting and it's actually slaved to the temperature of my VRMs on the motherboard. So in a case that the VRMs start to overheat, it will then start to suck oxygen over top of the motherboard and out the back of the case. Now, this really isn't going to happen unless I start doing some overclocking. So I basically have it running at its lowest RPM, which will help keep the GPU temperatures low as well. Okay, so now that we know how our fans are connected and why, we can start to mess with the curves. So here we're looking at our CPU input, which we know is the 3 fans connected to the radiator cooling down the liquid for our CPU. So they are connected to the CPU temperature, obviously. As we can see, there's not a lot going on besides the recording of this video. So the load to my CPU is not very high, and therefore the temperature sits pretty low. What I've noticed on my Zen 3 is that at idle temps, it's about 39 degrees Celsius to 45 degrees Celsius. So I set the lowest setting of my fans, which is a 20% workload, and you can see that here. I can't really go much lower than that. I set that at about what the idle temperature is, around 40 degrees Celsius. And then it slowly rises up to my threshold point, which is 80 degrees Celsius. But AMD says that their Zen 3 processors can go up to 91 degrees Celsius and operate normally. I don't really care to try that out. Maybe when we get to overclocking, it'll be useful information. But for now, 80 degrees Celsius, that's my threshold. My fans that are connected to the front also linked to the CPU temperature. It's a similar looking curve. My fan that I have connected to the GPU, again, fairly similar. Idle temps on the GPU go up to about 40 degrees Celsius. In fact, it's a little bit cooler than the CPU, so it can go as low as 37 degrees Celsius. And this all gets affected as well by whatever the ambient temperature is in your room. So, these are all going to be relative to your setup, which is why I recommend that you run everything standard and really get a feel for, what's going on when it's idle versus what's going on when you're running your applications, and what's going on at heavy load. So the AIO that I have is from EK, and it is capable of running at a variable speed. However, talking to the tech guys over at EK, the proper way to run it is pretty much at a standard RPM. You want to keep it at a fixed RPM. And I have mine at 69% workload, fixed all the way to points where I get to my extreme temperatures, and then I crank that baby up to 100. So what we can do now is test out what my computer sounds like when running at idle. So as you can see, it hovers between 19 and 21 decibels right next to the case, somewhere between a mosquito and a whisper. And the temperatures for the CPU are about 41 degrees Celsius, and the GPU was at 38 degrees Celsius. So pretty silent. I'm very happy with that. Now, if you want to see how your calibrations work at load, my recommendation is to load up your most intensive program that you're going to use and leave it running for a while. So Cyberpunk for 30 minutes in a crowded city area, that'll give you a good real-world example of what your machine's up against. But if you really want to push it to the limit, you can use some benchmarking software. So to stress the CPU, we have Cinebench. And to stress your GPU, we have the Heaven DX11 benchmark. So you can run these two at the same time to max out both the GPU and CPU load to see how your temperatures spike and then what they normalize at your current curves. We can run that test right now and listen to what the machine sounds like at load. All right, so I just shut down everything so that the computer can go back to its idle state, and I opened up the hardware monitor so we can see where all the temperatures went to. We did see that the sound hovered between 28 and 32 decibels, so solidly at a whisper. It is noticeably louder, but not so loud that you could hear it on your headphones when like you're playing a game. It wouldn't be noticeable, so that's perfect for me. We saw that the temperatures spiked for the CPU up to 71 degrees Celsius, which is very, very good, and pretty much stabilized at around 67 degrees Celsius. So that's also a really solid sweet spot. The GPU we saw climb up to and hold steady at 61 degrees Celsius. Again, I'm more than happy with that. So for me, these curves look pretty solid. In fact, gauging by these temperatures, it seems like we'd have a bit more headroom to keep the fans even quieter if we wanted to. But I'm looking for that balance between silence and performance. And right now, I feel very comfortable with where we're at. And looks like we might be in a good position to start to investigate some overclocking in the future. Now, again, I want to reiterate that I'm not a computer expert. I just wanted to share the information that I've discovered as I've spent the last few months tinkering with my machine. Now, like I said before, your results may vary depending on what kind of hardware you have and what environment you have it in. So definitely take some time to experiment incrementally. Start slow and then make your way up to that perfect curve. And in fact, I'm constantly re-maneuvering what my layout looks like. So yeah.
And so that's pretty much the whole shebang. I hope this was helpful for you. Again, I'm no expert, so if I did something wrong or you got a better idea, let me know. Hit me up. I do actually respond to y'all, especially if you leave me your Discord information. I will connect with you. So if you liked this video, if it was helpful, if you think my mustache is ridiculous, hit that like button and please subscribe. I appreciate it very much. And I'll see you on the next one. Bye.